In 2017, one study traced eclipse travelers across the United States. Domestic travelers covered about 700 kilometers on average. International travelers averaged more than 6,000. Ahead of the August 2026 eclipse, Spain expects 446,700 additional tourists as airlines, trains, and tourist areas also prepare. All for darkness that, across most of the totality path, lasts less than 2 minutes. At the centerline maximum, totality lasts about 2 minutes 18 seconds. The proportion remains. Days of travel for an event measured in heartbeats. We already know its date and path. So why does knowledge not make an eclipse ordinary? A solar eclipse happens when the moon blocks all or part of the sun. Its broad outer shadow, the penumbra, gives you a partial eclipse. Its tiny dark center, the umbra, gives you totality. On the 12th of August 2026, the umbra crosses Greenland, Iceland, northern Russia, the Atlantic, Spain, and a corner of Portugal. Most of Canada remains in the partial shadow. At 99% coverage, the remaining sliver of the sun still produces daylight and hides the corona. Cross into the umbra and the last direct piece of the solar surface disappears. The corona, the sun's normally hidden outer atmosphere, becomes visible. This is not a better partial eclipse. It is a different scene. The sun is roughly 400 times wider and 400 times farther away, so the disks appear almost equal. Because the moon's orbit is tilted, its shadow usually misses Earth. The geometry is predictable. The experience exists only inside that narrow line. Inside totality, ambient light dims rapidly, and the corona appears around a black disk. Depending on conditions, planets or bright stars may emerge, with a sunset-like glow around the horizon. The familiar rules of daytime have been suspended, but the landscape and the people beside you are still there. That combination matters. Psychologists often describe awe as a response to something so vast that our ordinary frame of reference has to adjust. Studies have associated awe with a smaller sense of self, although the effect varies with context and measurement. A total eclipse makes that scale physical. You watch the moon cover the sun and see the alignment change the light around you. Prediction can prepare you for the time. It cannot deliver the physical change in advance. In 2017, researchers compared eclipse-related posts from users inside and outside the path of totality. The odds that those in the path used awe-related words were about twice those outside it. In the study's first comparison, path users also used more collective and socially connected language and fewer self-focused words. This does not prove that every observer felt awe, or that an eclipse made people kinder. Location was a proxy for exposure. The users were not a representative sample, and words are not behavior. But a national follow-up survey found that 3/4 of direct viewers watched with friends, family, or co-workers. Each observer has a separate view, yet the countdown belongs to the group. That is not one hardwired reaction. It is people directing their attention to the same change at the same moment. Here is the apparent contradiction. Precise prediction should weaken the attraction. Instead, it supplies the coordinates for a pilgrimage. The umbra occupies a narrow strip and stays over any one place for only minutes. Miss the line or the time, and the experience changes. A forecast turns that scarcity into a plan: which town, road, horizon, and second. In Spain, the 2026 total phase arrives low in the evening, shortly before sunset, making the viewing location unusually consequential. So the map does not domesticate the eclipse. It concentrates desire. It tells strangers where to gather and governments where pressure will fall. It certainly removes the surprise of when. It sharpens the importance of where. Organizing a place around the sky is older than modern astronomy. Peer-reviewed work documents 48 late Neolithic pits at Bulford, 5 kilometers from Stonehenge, with dates centered on about 2950 BCE. In June, Wessex Archaeology announced a new interpretation. 2 lost wooden posts, roughly 120 meters apart, aligned with midsummer sunrise and midwinter sunset. The posts and alignment are reconstructed from pits, sky, and landscape. This concerns solstices, not eclipses, and is not evidence of eclipse prediction. The narrower point is enough. Before Stonehenge's famous stones, people were organizing a place around shared solar time. Around 1200 BCE, scribes at Anyang recorded eclipses on oracle bones. More than 3,000 years later, astronomers used those records to study changes in Earth's rotation. In 1919, teams photographed stars beside the eclipsed sun. The sun's gravity bent their light, shifting the stars' apparent positions. The result was evidence consistent with general relativity, although the early measurements were less decisive than the legend that the eclipse proved Einstein in one afternoon. Today, totality gives scientists access to the inner corona and lets them watch how the sudden, local removal of sunlight affects Earth's upper atmosphere. An eclipse can be ceremony, public spectacle, and scientific instrument without those roles cancelling one another. Science has made the shadow legible. It can calculate the path across a curved Earth and put a time against every point. Explanation does not shrink the event. It lets us be there to measure it. On the 12th of August, the calculation becomes a journey again. The total shadow reaches Greenland, Iceland, northern Russia, the Atlantic, Spain, and the edge of Portugal. Across most of Canada, people will see a partial eclipse instead. That may still be beautiful. It is not the transformation this story is trying to explain. Along most of the totality path, the complete covering lasts under 2 minutes. At its maximum, it reaches about 2 minutes 18 seconds. In Iberia, the low evening sun makes the western horizon part of the plan. Scarcity is not a marketing invention. It is built into the moving geometry. This is why the preparations look disproportionate only from outside the umbra. People are arranging themselves in space and time, so an immense event becomes physical, local, and shared. We still stop for an eclipse because predictability answers the wrong question. It tells us where the moon's shadow will be. It does not tell us what it will feel like when ordinary daylight fails, the corona appears, and a crowd looks up together. The evidence does not support one universal reaction. It supports a convergence, a rare physical transformation, a brutally narrow appointment, and attention shared at human scale. For most viewers in 2026, that appointment will be shorter than the time it takes to make a cup of tea. Then the bright edge returns, the corona vanishes, crowds disperse, and ordinary daylight returns. Except now, everyone in that narrow line has watched the same impossible-looking thing become real. Prediction did not remove the wonder. It told us where to meet it.